we have seen that linear probing is the collision resolution technique under open addressing, where the if the collision happens, then the next empty space is searched by linearly accessing the next available places. We are going linearly till empty location is accessed. From home address to empty location, we visit each and every space. Okay, that is linear probing. So, we have seen two types of linear probing in which we can use chaining. We can create manual chaining by using one variable, which is chain, which will store the position of the next element of the same hash value. Okay, like that, we can form the chain in order to reduce searching complexity. Okay, and also we have seen two different types: replacing and non-replacing. That is, if the home address it is occupied by same hash value element, then no need of replacing, it will be there only. But if another hash value element is occupying the home address, then whether to replace it or not. If so, that will be another part which will be using replacement or without replacement. Okay. So we'll see the implementation of both these algorithms. Just a minute. First we'll see without replacement, and then we'll go for the replacement algorithm. I hope this is visible. The code is visible.
Yes, sir.
Okay. So here, this simple hash function is used, mod size, and size is 10. Okay, we are not using any other further complicated logic, but you can design your hash function so that you can use any of the method like folding, med square, etc. that we have discussed. Okay. Out of that, you can select some methods and you can form the function, your own hash function, to which you will provide the key, and it will return the position where it should be stored. Okay, so this h of x is taking the key x and it is returning the position x mod size. So this is the simplest hash function, and we have also seen that if the hash table size is prime, it will work better. So you can select such size. Okay, here in order to uh, understand easily the hash value, I am using here mod 10. Okay, but you can design proper hash function. Now, in the hash table, what I'm doing is I'm storing the student data. Okay, so roll number, name, marks, etc. The hash table is storing the students data, and this status is nothing but a flag value. Zero is record is active, one is record is deleted. So status is nothing but a flag, and link, which is nothing but the chain. Okay, we have designed the hash table. I'll open the example so that simultaneously we can compare. Rupesh, can you ask the remaining students to join? Very few students have joined the lecture.
Yes, ma'am.
Okay, so we have discussed these examples, isn't it? Linear probing with chaining. without replacement and with replacement, and we have designed these hash tables where we have taken key, flag, and chain. Okay. So in our key, we are storing here the student data. Here, uh, in this example, we were storing the simple integer values, where now we are storing the student data, and we have the flag and chain values. Okay, that's why we have declared that record like this. Okay, struct student in this way. Then class linear probe, where okay, we will not use any file. We will be using array only to store the data. So table of 30. Here we will not be combining it with file logic. One minute, I'll just check whether that simple program is available or not. So it will be simple array which we will allocate, and we will store the data in the hash value which is calculated. I'll go for the simple logic. Yes, I'm having that program, but C program is there. It's okay. We will concentrate on logic only. One share it again. Yes. Hashing to handle collision using linear probing with chaining without replacement. Okay, and here the program is in C, but you are expected to write CPP program. Okay? But the functions will be similar. Okay, so here simple integer data is again used, flag, okay, and chain value, like the table which we have created. Same three arrays are created: data, flag, and chain. You can have a record also, in which you will have int data, flag, and chain, and you will create array of that record. That is also fine. Okay, so here individual three separate arrays are taken. You can take single array of records, no problem. Okay, then in main function we will be take initializing first the hash table, like flag of I is false and chain of I is -1, which we did when we solved the example. We started with the same. We wrote 0 for every flag value and -1 for every chain value, isn't it? So similarly, we will initialize our tables here. The hash table will be initialized with flag and chain, and then We have the options insert, search, and print. Okay, so insert is for inserting the key, search is searching a particular key in the hash table, and print is displaying that hash table completely. So in the insert, we are taking the key from the user. This X is the key, and we are calling insert, where all these data, or you can have your own structure, array of structure that you can pass. Okay, add the key you have to pass to be inserted in the hash table. So in the insert function, now the logic for insertion is chaining without replacement. Handle collision using linear probing with chaining without replacement. This logic we have to use in order to insert the key. Okay. So first step is to calculate the hash value of the element which we want to insert. For that particular key, we have to calculate the hash value. Okay. So start is nothing but the home location, which is obtained by calculating the hash value. Then we will have to check whether this start is free or not. If it is not free, then you have to go to the empty location. Okay. So while flag of start and I is less than size. So while flag of start means until flag of start is 1, then you have to move ahead, okay, to the next place till empty location is accessed. So if flag of start that same space, same home location, it is free, this loop will stop there only. If it is 0, flag is 0, it will stop at that moment only. Otherwise, what we are doing, we are applying here the function. We are checking whether data of start mod size is equal to x mod size or not. That means the hash value of the elements is matching or not. The hash value of the element present at that start location and the current location, whether we are getting the same hash value element or not. So until we get that same hash value element, we have to move ahead. Start equal to start plus 1 mod size. Okay, and break will execute when same hash value element is found, that is start of the chain is found. Okay, here in chaining without replacement algorithm, we cannot guarantee whether the same hash value element is present at its own location or not. Okay, that means chain of 5 will start at 5 location 5 or not. It may start at 6 7 if 5 is already occupied by other keys. Okay, that's why we need to search for start of the chain here. Okay, so locate the beginning of the chain. Here in chaining without replacement algorithm, we need to locate the beginning of the chain first. And once the beginning is obtained, the start of the chain is obtained, then we have to use just access that chain until we reach to the end of the chain. So this loop will take us to the start of the chain. Okay, so start will be now pointing to the start of the chain, beginning of the chain. Suppose hash value of the element which is to be inserted is 5, then it will take us to the beginning of chain of 5. Okay, now we will check here whether the loop has ended because of this condition. That means if the table is full, then we go on accessing each and every location, and we come to the same place again. So if I equal to size, that means we have accessed all the, suppose size is 10. Then if we have accessed all the 10 locations and we could not locate the beginning of the chain, then we need to say that hash table is full and there is no chain of the required hash value. Okay. That's why we need to return from there. We cannot insert. If table is full, we cannot insert. Okay. That's why this condition is there in order to check whether the table is full. So I is initially 0 and we are incrementing I. Okay, when we are accessing next space, the I will be incremented, and when I reaches to size, that means we have compared with all 10 elements, but start of the chain is not located. So in that case, we will return as it is. We cannot insert. Okay, but if the loop has ended because of this break condition, okay, that means we have located the start of the chain. That might be the same location 5, or that might be 6 7, any location where we have matched the hash value. Okay, then After we get the beginning of the chain, we have to access that chain, follow that chain till end of the chain. So go to the end of the chain. This while loop will take us to the end of the chain. So while chain of start is not -1, we know that chain of the last element is -1. So while chain of start is not -1, start equal to chain of start. Okay. So start will be taken to the last element of the chain. Okay. So initially start will point to the beginning of the chain, and this loop will take that start to the end of the chain. Okay. Now after we now our start will point to that end of the chain. Now we have to search the empty location where we need to insert that particular element, okay, or key. So j equal to start. So from that last element of the chain, we will now start accessing next location till we reach to the beginning. We reach to the empty location. So while flag is j, that means that particular place is occupied, and I is less than size. J equal to j plus 1 mod size. That means we are accessing here. We are applying linear probing. Okay, we are applying the linear probing, and I equal to I plus 1. So if I is size, okay, if I has reached to size, that means we have compared with all the elements, but still empty location is not obtained. In that case also, it will say that table is full and return. Okay, means start of the chain is obtained. End of chain is also we have reached to end of the chain, but there is no empty space available. Okay, in that case also it will say hash table is full. Otherwise, we have reached to the empty location, and at that empty location we have to copy the key. So data of j is equal to x. This is insertion of the key at the empty location, and then we have to modify the chain value also, because we have inserted one more element in the chain. So flag of j is true, and if j is not equal to start, chain of start equal to j. That means if this is the first element, then j and start will be same value. Okay. Otherwise, our start will be at it will be pointing the last element of the chain, and j is pointing to the empty location. But if this is the single element of that chain, then j and start will be same. Okay, that's why if j is not start, then modify the chain value. Chain of start is equal to j. Okay, are you getting any doubt in this insertion, where we have followed the algorithm chaining without replacement, linear probing using chaining without replacement? Okay, so here we first searched for the start of the chain. After the start of the chain is accessed, we are moving that start pointer to the end of the chain. We have followed that chain till the last element. Then we searched for the empty location. Okay, this is the searching for empty location, and then at that empty location we inserted the data, and we then modified the chain value, previous chain value. Okay, are you getting any doubt in this? We have already discussed the examples. If this is clear, then searching is also on the similar track. Any doubt in this? Are all the conditions clear? Please respond. Yes. Okay. So searching is also on the same track, where we are now. This is the hash table. Okay, all these three arrays, and this is the key. Okay, and here also we first calculate the home address. J is equal to h of x. This is the home address. Then here also we have to first locate the beginning of the chain, because we cannot guarantee whether the chain is starting at the home address or not. So we have to search for the beginning of the chain between home address to empty location. Okay, so until I is less than size, I is initially 0. Flag of j means it is occupied, and when we reach empty, then we'll conclude that there is no chain of that hash value, and so element will not be present. Okay. And also if we reach to the size, that means we have compared with all the elements and we could not get the beginning of the chain. Otherwise, if the hash value is matched, data of j mod size equal to not equal to x mod size, that means same hash value element is obtained. So in any of these three cases, we will end the loop. Okay. Otherwise, we will be moving to the next location like this. Okay, until we reach either empty location, or we have reached the we have compared with all the elements and we could not reach the empty location. Okay, or the beginning of the chain is found. So in any of these three cases, this loop will end. Okay, and we will check here whether the flag is uh, because of these two conditions, whether the loop is ended or not. Means we reached to empty, or we compared with all the elements and we could not trace the beginning of the chain. So if this is the case, we will return -1. That means not found flag. Otherwise, we will say that the loop has ended because beginning of the chain is found. So we will access that chain. Okay, in the same way, like we did in insert. So while j is not -1, data of j equal to x. If data is also matched, so chain value is matched. Now we will access all the elements of the chain until we reach -1. And while accessing, we are comparing with the required key. Data of j is compared with required key. Okay, so comparison of the key is done only with the own hash elements. And if the data is matched, return j. Otherwise, j equal to chain of j. So now we are comparing only with the own chain elements. Okay, after we get the beginning of the chain, then we compare with only own chain elements. Okay, and if the match is found, we are returning that position where that element is present. Otherwise, we will return -1. If we reach to -1, that is end of the chain, and still the match is not found, then we will return not found flag. Is it clear how to search? So here searching complexity is less. Imagine that this hash table is a very huge hash table with thousands of entries. So we are not comparing with each and every entry like linear search. Okay, and we cannot guarantee whether the elements are in any order, ascending order or descending order. So we cannot apply binary search also in this. So this is also hashing is also a very good technique for searching. Okay, where the complexity depends, searching complexity depends on the hash function which you have selected. Okay, and we are comparing the uh, elements with own hash value only. We are not comparing each and every element. Okay, after we get the beginning of the chain, then we access only that chain element and compare with only the same hash value elements. Okay, so complexity is less than big of n. If and in very worst case, if all the elements are having same hash value, then only the comparison will be done with all the elements. Otherwise, if every element is having different hash value, and if we have used very proper hash function and good hash collision resolution technique, then we can guarantee that it is hashing is a good technique for searching. Okay, any doubt in this? Shall we go for the next algorithm, chaining with replacement? If this is clear. Yes, can you respond? Okay, fine. Now we'll go for the chaining with replacement algorithm. So here also, I'll try to execute both the algorithms afterwards. Okay, same function, x mod size, and size is declared as 10. Okay, and other two macros are defined, false 0 and true is 1. Then we have similar three arrays, data, flag, and chain. Okay, and we have declared initialized all these three arrays in the similar way. Flag is false for every element in the hash table, and chain is -1 initially. Okay, then in the insert function and search function, now we are following linear probing with chaining with replacement algorithm. Okay, so key is taken, and this is hash table and key, which are input for the insert function. Now we'll go here to this function, insert function, and here the difference is, here we can guarantee that if the chain is starting, chain of 5 is starting, it will start at location 5, otherwise that chain is not there. Okay, so here start is equal to h of x, home address calculation. Then if flag of start is 0, that means it is empty, then we can immediately copy the data and uh, modify the flag there. Okay, and return. So here we are checking whether the that home address location is empty or not. If it is empty, immediately insert. Otherwise, we have to, the situation 2 is hash location does not contain a synonym. In this case, we have to replace. Okay, and third situation will be hash location contains synonym. If it contains the synonym, then you have to access the chain till end of the chain and search for empty location and insert in that empty location. But the situation 2 is somewhat critical, where it does not contain the synonym and you need to replace that particular element. Okay, so this replacement is a tricky part. So original value, if it is not there, then that means hash is not matching. Hash of data of start, okay, the value which is present there, data of start, it is not having same hash value like our key. In that case, we need to do the replacement. Okay, so I is 0, j is start. Okay, start means our home location. Now while flag of j and I less than size, so here we are searching for the empty location, j equal to j plus 1 mod size. Okay, so j will point to the empty location after this loop. There, if I is equal to size, that means table is full and we cannot insert the new value. Otherwise, j is pointing the empty location, and that we will use ahead. Okay, then now this is important. I is equal to data of start mod size. That means we are calculating the hash value of the element present there. That means, see, suppose I am inserting 45, its hash value is 5. Okay, but at that position, suppose 34 is present. So I am calculating what is the hash value of element present there. Means what is the hash value of the element 34 is 4. Okay, so I is nothing but the hash value of the element present there. Okay, and I will check of which chain this particular element is part of. Okay, so that is part of chain 4. 34 is, it is part of chain 4. Okay, so I'm searching that particular thing. Okay, so I is equal to data of start mod size. Because I need to replace that 34, I should know it contains, it is the part of which chain, so that I can replace it easily. Okay, and I will access the chain of 4 first. Okay, because from that chain I need to shift the element. So while chain of I is not equal to start, I is equal to chain of I. Okay, we'll go to our example and we'll discuss this condition. See here, when we discuss this example, okay, uh, suppose I want to insert in this table 34 value. Okay, 34. But one, this is having a function, hash function is mod. If we'll go to the next example. Your hash function is mod 13, isn't it? And if I want to insert a particular element, suppose at location 2. All these are actually replaced values, so will not get the condition like that. We can start designing one more simple table. This is mod 10 hash function for mod 10, and suppose here some value is present 33. I'll not write the flag here. Then 54 is also there, which is changed to 5, and here we have 54 percent. So this is the condition, suppose, and one more element is present here 66 times 64, and this is also chained to this particular element. Okay. So this is our hash table. Okay, and I want to insert now in this table, suppose 55. Okay, which has the key 55 and hash value is 5. So I'll check the home address. Hash value 5 is already occupied. Okay, it is occupied, and the chain value is the hash value is not same. It is not synonym, isn't it? Hash value of 55 is 5 and hash value of 34 is 4. So I need to replace now 34 to the next empty location. Okay, so what I will do is I have calculated this, and as 5 is not empty, this location is not empty, this is the first element of chain 5. That's why I need to shift 34 ahead. And this loop, this particular loop, what it has done, it has searched for the empty location, j equal to j mod j plus 1 mod size. So j is pointing this empty location. Okay, and this is our start location. This is our start location. Now what we are doing here, we are calculating now hash of the value present at that home address. So the hash is 4. Okay, so now we are starting accessing the chain of that particular hash value 4. Okay, so while chain of I is not equal to start, I equal to chain of I. Okay, so we have started the accessing chain of 4, this, and until it is not pointing this required location start, this is start location 5, isn't it? So until in the chain we don't come to this element which is pointing to the current start location, this 5. Okay, till that time we will access the chain. So here immediately we are getting chain value 5. Now we need to, what we will do now, after we get that element, okay, that ith place, then chain of I is equal to chain of start. So we will say that it should directly point to this element, next element of the chain, which is at present at 7. Okay, so instead of pointing this element which is present at 5, directly point the 7th place element. Okay, so here it will modify the chain to 7. Instead of 5, it should point to 7, this element. Okay, so we have updated the chain value, and now we can insert the element at that particular place, isn't it? This is clear. We have modified the previous chain value, and then we will complete that chain. While chain of I is not -1, I equal to chain of I, so we are moving to the last element of the chain. Okay, so I will point now this. First we have taken a halt where I is pointing to the start location, and we modified the chain there. Then we access that chain till end. So I is now this particular location where chain value is -1. Okay, the last element of the chain, and we will modify the this to value 8, because we will modify it to value 8. Okay, because we are now inserting the element at that location. This 34 we are shifting at that location, and that will be the last element of the chain, like this. Okay, so this shifting will take place completely. Are you getting? So we have modified the previous value of the chain, and the last element of the chain, which was 64, its its chain was -1, and we have modified it to 8. That is the last location where we will shift now the element. Okay, so while chain of I is not -1, I equal to chain of I, this will be last element of the chain, and then chain of I is j. Okay, that is the empty location. So here completely the shifting uh, was done. Data of j is equal to data of start. This is actual shifting. Okay, and chain of start is -1, because this is now the uh, our empty, our location is now empty, our home location is now empty, where we can now insert the new value. Okay, the value key, the key will be inserted at the start location. Okay, after shifting is done properly, we are now inserting the value required key, which is 55, at that location with chain value -1. Is the shifting clear? Is the shifting clear? So this I, that is the hash value of the element which is present there. We have started accessing the chain of that particular element, and we took two halts in that. First, when uh, that chain value is pointing to the start location. Then we took a halt when that chain ended. Okay, because we need to modify the chain value of that also. And then we did actual insertion, actual shifting, and actual inserting of the key. Okay, this is the second condition where we need to do the replacement. Hash value is not matching. And third situation is when hash value is matching. In that case, immediately you will be accessing the, we will be searching for the next empty location, and we will insert at that empty location, and we will modify the chain value. Okay, chain will be accessed from start to the last location, and immediately that last of the end of the chain will be modified. Is the insertion clear? Here insertion is complicated, but we'll see the search logic also, which is simplified now than the without replacement algorithm. Is the shifting clear? Replacement is clear? Shall we go for the search function? Discussing the search
Yes,
function
ma'am.
today? Okay. So in searching now, we are sure here that if the chain is starting, it will start at its own home location. Otherwise, the chain is not present. Okay. So j is equal to h of x. We are calculating the home address, and here similar in the similar way, if I is less than size or flag is j, or if the uh, data of j mod size is not equal to x mod size, in that case, mm, here no need of beginning searching for the beginning up. So you need to modify this function. I'll not show this function, it is not proper here. If the chain is present, directly start accessing that chain. Okay. And if this hash value, same hash value element is not present there, you need to directly conclude that it is not present, the element x is not present. Okay. Otherwise, we have to consider that same hash value element is present and directly access the chain and compare with only own chain elements till we reach -1. Okay. Compare with only own chain elements, no need of searching for beginning of the chain. Okay. So I'll not show this hash search function, it is not proper according to the logic. Okay. With replacement logic, I hope the difference is clear now. So if we want to search here in our example, okay, if I want to search for suppose 34, what I will do, I will only start accessing from location 4, and I will compare with this element, I will compare with the 7th element, I will compare with the 8th element until the end of the chain is reached. So I'm comparing only with the own chain elements. Okay. If I want to search 77 and here synonym is not present, that means chain of 7 is not present. I will directly conclude that it is not present. Okay, no need of comparing with anyone. Just check the hash value. If it is not synonym, that means chain of 7 is not present, and I can immediately conclude that 77 is absent. Is it clear? But in case of chaining without replacement, we cannot guarantee whether the chain is starting at its own location or not. So we need to search for the start of the chain, and once the start is obtained, we have to compare with only synonyms. I hope both the algorithms are clear now. If you have any doubt from your side as you have started preparation, you can ask.